So now we're going to discuss some new notation and new terminology. But before we get into that, I'm going to recall some facts. So the first one, remember that A divides B if there exists an integer C such that B equals A times C, and the notation we use here, A divides B. And I also want to remind you of a relation we saw back on worksheet 5. So say recall the relation from worksheet 5, and it was the relation, I'll say, on Z from worksheet 5, and the relation was X relates to Y if 3 divides X minus Y. So you should have shown in worksheet 5 that this relation is an equivalence relation. So that's what you should have been able to show. We're not going to go into the details here because it was on your worksheet, but we're going to use this to define some new terminology. So I'll say in this case, we say X is congruent to Y modulo 3 if 3 divides X minus Y. X is congruent to Y modulo 3, and the notation we would use here we're going to use would be X and then 3 lines. X is congruent to Y mod 3, modulo 3. So you can actually define this in general, not just for modulo 3, but you can do modulo any positive number that's at least 2. So that's this definition we're going to define now. For integers A, B, and N is at least 2, A is congruent to B modulo N, if N divides A minus B, and the notation we're going to use is that X is congruent to Y mod N, modulo N. So here all we've done is change what we're dividing by. Before we were dividing by 3, but here we're dividing by N, and N is at least 2. So anytime you come across a new definition, you want to look at some examples to make sure you understand the definition. So let's look at a few examples here. So I can say that 24 is congruent to 6 mod 9 since 9 divides 24 minus 6. 24 minus 6 is 18. And 9 divides 18. Okay? So let's look at another one. 1 is congruent to 5 mod 2, and that's because 2 divides 1 minus 5. 1 minus 5 is negative 4. So I can say 2 divides negative 4. Okay. Four is congruent to 4 mod 5. That's because 5 divides 4 minus 4. This just says 5 divides 0, which is true. And let's look at two numbers that aren't congruent. So, for example, 8 is not congruent to 2 mod 4. That's because 4 does not divide 8 minus 2. This says 4 does not divide 6, and 4 does not divide 6. Okay? So you take your two numbers, you take their difference, and see if n divides their difference. So when n was 3, we said that this relation was an equivalence relation, this congruence modulo n. And so does that work for any value of n? And the answer is yes. So that's this theorem 9.14 says just that. It says let n be in Z, where n is at least 2, then congruence modulo n is an equivalence relation. On the integers. So no matter what n is, as long as n is greater than or equal to 2, congruence modulo n will always be an equivalence relation. So it'll be reflexive, it'll be symmetric, and it'll be transitive.